Hello, good morning. Welcome back to my channel, JBTeguihanon, Engineering and Chemistry Tutorial. So let's continue our topic or our study of refrigeration system, but we are now reviewing the basic properties of matter. So last video we have discussed the matter, right? Matter is commonly explained as a substance that occupies a space and has mass. And then matter exists in three states, right? Or we call it sometimes phases: solid phase, liquid phase, and gases. Okay, an example is water. Water has a solid phase called block of ice or ice. You can see it in the form of big block of ice. And then in our houses we have ice, cube ice. Okay, and then we have liquid, and then we have gaseous. Okay, here in figure 2.1 we have solid phase of water. In figure 2.2 we have liquid phase of water, and in figure 2.3 we have the example of gas. Okay, so gas molecules travel at random. When a container with a small amount of gas pressure is open, the gas molecule seems to repel each other and fly out. Okay, and now today we are going to study mass and weight. Okay, so mass is the property of matter that responds to gravitational attraction. So it is the property of matter that responds to gravitational attraction. Weight is a force, it is not a mass. It is a force that matter applies to a supporting surface when it is at rest. Okay? Weight is not a property of matter but is dependent on the gravitational attraction. The stronger the force of gravity, the more an object will weigh. The Earth has stronger gravitational attraction forces than the Moon. This is why objects weigh more on the Earth than on the Moon. All solid matter has a mass. A liquid, such as water, is said to have mass. The air in the atmosphere has weight and mass. When the atmosphere is evacuated out of a jar, the mass is removed and the vacuum is created. Okay, this is the definition of mass and weight, the difference of mass and weight. Okay, and now uh, let's go to thermodynamic textbook and let us see here an example so that we are going to uh, understand it better. So in here in example 1.2, Newton's second law states that force is equal to mass, small m, times acceleration, or small a. Okay, this is the second law of Newton. In every action, there is a reaction. Okay, this relates a net force acting on a body to its mass and acceleration. this relates a net force, okay, that is a net force on a mass, or sorry, on a body to its mass and acceleration. So what he is saying here is that if you have a mass at rest, right, an object, particle object at rest, somehow you apply force in here, you're pushing it to the right, okay, and successfully you have moved it here to the new place, okay. In order for you to do that, okay, this is now the new place of this M, okay. This circle here, or this mass, has a mass. I call it M. So when you apply this force from left to the right, if this force have net force, means it's overcome the weight or the M and allow this M to move from here to there, then your F, okay, this F is said to be equal to M times acceleration, because this accelerated from D1, shall we say D1, or initial DI, to final DF, distance. So this is what he's talking about, the second law of Newton. So the net force acting on a body to its mass and has acceleration. Acceleration is just the rate of motion from the initial to the final. Okay, from what I'm saying, from here, okay, when you apply this F and it has a net force to overcome M, then M, this M, accelerate from the initial to the final, to this location here. It moves, okay. So if a force of 1 Newton, if a force of 1 Newton of mass M, of a mass 1 kilogram at 1 meter per second square, a force of 1 pound force accelerate 32.2 pound mass or one slug at a rate of 1 feet per second square. How are the units related? So we're talking about the units here. So what he is saying is that this is just a conversion. 1 Newton is equal to 1 kilogram, kilogram mass, times a distance of meter. Suppose this is a meter. Meter means unit, not meter mass, over square of a seconds. Square of a seconds, or this one, sorry, this one is your acceleration, and and this one is your M, mass. So this is unit analysis, and your force is in Newton. So in that is in SI system. What about English system? In English system, your the unit of your force F is equal to m times acceleration. In English system, your F is pound force is equal to 32.2, and the unit of your M is pound mass, and the unit of your A is feet per second square. So this is again, okay, this one is equal to F is equal to 32.2 pound mass per square, feet second square. So this is how it works. This is just a what you call that, a unit of system. Okay. So what the key here is your force formula is equal to mass times acceleration. So depending on the question, you have to be consistent with your unit mass. If this is in English, that your M must be in English and your acceleration must be in English system. If you're dealing with the unit SI, System International, your your F force is equal to mass times acceleration. This must be in kilogram and this must be in meter per second square. Okay, just remember that is the key in solving Newton's law problems. Okay, that is actually uh, the difference of force, weight and mass are incorporated in this problem here, right? The mass is there, M, and the weight is there, and that is force. Okay, so thanks for watching. Please do subscribe to my channel, and please hit the notification bell, and also do like my video. Thanks for watching again. Bye for now.